Burning Man, the vibrant, colorful art festival in Nevada, if you walk up, there is a booth that says, "Talk to God." Now, let's not get religious, but curious, right? Would you walk up and pick up the phone and see what God has to say? Well, 2 years ago, if you had gone and picked up the phone, the voice of God on the other side had a very strong, thick Indian accent. And that was me. So I spent days just a couple of 100 meters from this old-style telephone booth listening to folks. And amazingly, the fellow Americans shared and poured their hearts out talking about their dreams, but often their challenges and frustrations. And they thought somehow there is someone who can see everything, can talk to everybody involved, and maybe even resolve and provide them guidance. This was a very moving experience for me as a human being, but also as a scientist. Why did they trust me with all their deepest secrets? And when I came back to MIT, I and my team thought, this is what we need for the society to move forward. We need a trusted, impartial, honest broker who has an all-seeing, all-knowing view of what's going on, but not through a kind of a Big Brother Orwellian system, but maybe a newfangled AI that's benevolent. And we look at the Eye of Providence on our dollar bill, and if you believe Nicolas Cage from the National Treasure, it's all-seeing, all-knowing. And frankly, it's not going well. We don't trust most of these systems. Who here loves the Google Maps, the reds and the greens for the traffic? I mean, isn't it amazing? We just casually give away our privacy, our GPS location, and we get so much utility out of it. Imagine if we could do the same thing for everything else. If there's a treatment for diabetes or treatment for another challenging disease, if millions of people worldwide would just share their health data and their treatments, we can probably solve some of these problems overnight. So we have this dichotomy. Either we get privacy or we get utility. And the question for us is, can we create a privacy-preserving AI that can achieve both? Now, of course, we're going to say this is nearly impossible because we care about consent, we care about the regulations, and of course, there are trade secrets, and it's just too private, too confidential to share all this information. And even if we can, the quality is going to be horrible. Google is great at collecting that data, but who's going to put together all this information? And what's the incentive for people to do this? But you'll agree with me that if we can solve this privacy utility trade-off, we'll transform not only our health, our transportation, but maybe on our democracy. And some of us might say, I really have nothing to hide. So just like I give away my location data, I'm happy to give away everything else because I really have nothing to hide. But sometimes it's not just about you. It's about others around you as well. So the challenge for us when we hear about word like privacy, it's very egocentric. And we understand issues like identity fraud or job discrimination, but we don't really tie that to an Orwellian all-seeing system that's out there. So at individual level, we understand that if you visit a mental health facility, maybe this Orwellian AI could lead to job discrimination. But also affects at the organization and even geopolitical level. Imagine if a large company can buy the data of just the locations of all the employees of a smaller company and figure out all their plans. So a lot of the trade secrets are going to spill out. And even at geopolitical level, Strava, who is a Strava here? Beautiful app to keep track of your outdoor activities. Strava decided to release a heat map that in aggregate, in an anonymized way, shows the trails of every individual that's using Strava for running and walking and so on. Well, it turns out it's mostly used by Westerners. So the army front bases of the US Army in Syria and Niger were completely exposed because only the US Army men were using the Strava maps. And in Taiwan, the locations of their very secret defense facilities were exposed by looking at those trails. And we are not even talking about the possibility of a rogue entity just buying the raw data from a Strava employee and figuring out if people working at those military facilities, what their traces are when they go from one location to the next location. So it's kind of scary. So privacy is not just about us, it's about everybody around us and also at the national and geopolitical level. So obvious reaction would be, let's do regulation. But most of the world actually lives in an unregulated way. The app that you download from some strange country and strange app developers is often not regulated where you are. And even if they do, it's not going to end up creating this benevolent AI that can actually solve the societal problems by aggregation. So there's some good news. So for each of these problems, my team at MIT, but many researchers all over the world, are developing techniques that can preserve privacy and still make it available for societal good. For privacy, we have techniques such as split learning. For quality, there's automation of machine learning. And for incentives, there are new types of data markets. So what does this honest, trusted, impartial broker need? First of all, it has to be decentralized, much like internet, not owned or controlled by any single entity. It needs high quality, precise data. It needs to learn from wisdom, because data turns into wisdom, and wisdom learns into what machine learning can use. And this broker also needs an ability to act, predict for a given task. Now, these are tall orders. It's not easy to solve each of these pieces. So let's look at what has happened. Originally, we thought humans and our activity will generate data, and that can be used for statistics, and that can be used for everyone else. So humans to data. But the challenge in today's world, in the Orwellian AI, is that the data and the statistics has started identifying an individual. The example I gave you about Strava and your mental health and job discrimination. So it feels like the key enemy of privacy is actually the precision, the fact that the data is so pure. And that's the first step in taking back this challenge. Why should an app need your exact, precise GPS location when we can just add some noise to it, blur it a little bit, create a random location that's within a quarter mile, so it doesn't reveal the fact that you went to this mental health facility. At the same time, if you want to see the traffic and how many folks are roughly on the street, it's still good enough in aggregate when you average them to see the reds and the greens on the map. And this is a very powerful idea. In fact, the census in 2020 is going to use this notion of taking a raw census data, adding some noise, and releasing it available for the public and also for researchers. And it'll be available on a block-by-block basis in terms of education and employment and race and social factors and so on. And of course, because of this technique called differential privacy invented by Cynthia Dwork and others, we can guarantee that the data does not reveal anything about the individual, but the data is enough to talk about everyone in aggregate. So that's a very powerful way to get started. So on the horizontal axis, we have different ways to think about privacy. As we saw, anonymization is no good with the Strava example. And at the same time, using overlapping data sets, it has been shown many times that anonymization is not at all useful. A slightly better technique is to add noise, as we saw for GPS location. Probably the best way to achieve privacy is to keep all the data encrypted. Of course, there's a trade-off. If we anonymize it, we can learn a lot from it. If we add noise to it, unfortunately, it's difficult to do something more sophisticated other than doing aggregate queries. And encryption, of course, limits to what we can do. So to create this private AI, the key concept is not just to add noise, but instead of adding noise, think about how can we convert data into wisdom and only share the wisdom, but not the raw data. And that's where the privacy can come in. And two major techniques have emerged just in the last 2.5 years. One called federated learning from Google, and another technique called split learning from our group at MIT. So let's take an example of medical diagnosis and treatment plans. Let's say we want to create a master algorithm that detects pneumonia from chest X-rays and suggest the best treatment plan by looking at hundreds of thousands of patients. And imagine you have about 100 hospitals. Each of them have chest X-rays and treatment plans, but because of regulation and privacy, they cannot share it with the central facility. So what can we do to solve this problem? Well, the good thing about software versus AI is that software is wisdom from rules. So it's more like cooking. There's a procedure, you use the ingredients, and you get an outcome. It's a rule-based system. AI, on the other hand, is wisdom from examples. And so AI is more like raising a child. I would show a lot of examples to my daughter about how to eat and how to talk and how to walk, and she's going to learn from that. And the fact that AI is wisdom from examples allows us to actually create a new type of privacy. So if you want to create collective intelligence, what I could do is I could take about 100 medical interns and send them to those 100 hospitals and ask them to just train in each of those facilities. Maybe one hospital has more smokers, one hospital has elderly, another hospital has a particular demographic, another hospital has different nationalities. And after they have been trained for 3 months, each medical intern won't be as good as figuring out interpreting the chest X-rays and treatment plans for every other type of demographic in other hospitals, but they'll be good enough to do what they do in that one particular group. I can call all these 100 interns back to my office, and suddenly I have collective intelligence. I can just take an average of all those interns, and when a new chest X-ray shows up, I can show it to these 100 interns and say, hey, what do you think? And they can give me a pretty good answer. And in this process, I have not asked for raw data from any of those 100 hospitals, but I have a collective intelligence from all these entities. So this fascinating technique is called federated learning, invented by Brendan McMahon and others at Google. And this is already being used on your Android phones. Let's look at it another way. You all know about the elephant and the blind man. So imagine the 100 interns go out, and instead of learning from all those X-rays with possible pneumonia or not and coming back, imagine the interns just take notes. And they're going to make a lot of mistakes. They're going to say, hey, this looks like a fan. This looks like a spear. This looks like a rope. And they're going to convert the raw X-rays into a whole bunch of features. And they can send them to the center, and the center will say, I never got a full picture of an elephant, so I'm going to preserve the privacy of the elephant, but now I know what this is. I know what a pneumonia looks like. And this method is called split learning, as I said, from our group, and it's a way to create a master AI from wisdom. So each of these interns can take notes for every patient and convert the raw data into wisdom. We call it smashed wisdom. And this smashed wisdom is sent to create the master AI algorithm. So pretty straightforward ideas, right? Of converting data into wisdom and wisdom into AI and preserving privacy of individual patients. And of course, we want to do that with sophisticated machinery, sophisticated digital tools. And that's this newfangled AI that's privacy preserving. So we're living in an interesting world where we could get the best of both just with some software. So my group members, Utkarsh Gupta, Pranit Bakapokama, and Abhishek Singh are working on this problem, and they're releasing a lot of code on this split learning. How do we split the learning between what happens in the hospitals and what happens at the servers? And of course, once the master AI is trained, and it's really good at detecting pneumonia or suggesting the treatment plans, it can be shared worldwide. And for some reason, if the server wants to keep it a trade secret, that's fine too. You know, a new hospital in Philippines can just send an X-ray, not in its raw form, but with smashed wisdom out of it, and convert that and get this response. So just make sure I state this in the machine learning language, the technical language. We can take a deep neural network, and the early layers of the network execute at the hospital, and the later layers of the deep neural networks execute at the server. And we convert our raw data, in this case X-rays and notes, into an intermediate representation, which we call smash wisdom, and the smash wisdom is sent to the server so it can finish rest of the training. And at the inference time, this hospital in Philippines can again convert their X-ray image into this smashed wisdom, a smashed representation, and get a response back from the master algorithm. So this is how these systems can work. So far we talked about a solution for privacy using techniques like federated learning and split learning. What about the quality? If you really want to create a benevolent AI, the likelihood that every entity will have talented machine learning engineers and data scientists and folks who put all this together and curate that is unlikely. So a new set of techniques have emerged called automated machine learning that can not only figure out how we can do the janitorial work on all the data, on all the information, but can also figure out the best technique that applies to that particular information. And then finally, even if all this is working, what's the incentive for those 100 hospitals to participate? Maybe they should get paid. Maybe some of those hospitals have some really unique data sets, some really unique patients who should be monetized for that. Or there could be other incentives beyond money for them to participate. Nevertheless, we need a stock market that's possible for AI, that's possible for data that turns into wisdom and turns into AI. So these are some of the techniques that we think will mesh together to create the benevolent AI. So the next time you see a booth that spikes your curiosity, talk to God. Don't just click on those buttons that says, I accept, all those forms that you fill in, or you never read the privacy agreement that you're signing up and signing away your life. Because something as low stakes as your location can be actually very, very important. Maybe not to you, but people around you and even the places you live in. At the same time, we can't be too paranoid and say, I don't want to share data for a benevolent AI, because now we have a mechanism to convert data into wisdom, and that wisdom will create a benevolent AI. So let's fight for our freedom. Let's get our data in the right place. Let's solve big societal problems using benevolent AI. Thank you.